Hi, my name is David Granade, and I'm a fluid power specialist with John Henry Foster. I have 45 years of experience in hydraulics and pneumatics. I also am the corporate trainer. One of the things that I want to talk about today is that commonly we get called with customers complaining about their systems running too hot. And more often than not, that's due to having a pressure compensated pump in the system and the fluid being dumped over the relief rather than over the compensator, creating heat. Before I talk about that any further, I want to give you a little bit of background on systems so that maybe you'll understand more about what I'm talking about. To begin with, the pumps that we use in the hydraulic systems are one of two types. They're all positive displacement, and the flow is dependent on the input speed and the displacement, primarily used in fluid power. The first one would be a fixed displacement gear pump. The second one is a variable volume pressure compensated piston pump. Here's a cutaway of a gear pump. The way that a gear pump functions is as it rotates, fluid is drawn into the pump, works its way around the outside of the gears, and is pushed out downstream. Here's a variable volume piston pump. What normally happens with a variable volume piston pump is as it's rotating, and it's at this cam angle that it's showing here, which is maximum displacement, half of the pistons are intaking fluid and half of the pistons are exhausting fluid. The picture below shows a pump in the compensated mode, where this swash plate shifts to neutral, all right, with zero cam angle, and now the pump pistons rotate around in the cylinder block, but they don't displace any fluid. It just holds the pump at the compensator setting. Here's another angle of the variable volume piston pump. This is showing that swash plate, and it's at the maximum cam angle. Up top is my pressure compensator, and that's what is used to shift that pump from fully on stroke to compensated. All right, so as long as the system pressure is below the setting of that compensator, the pump is at full stroke. But when we get to the point that we have reached our compensator setting, then what occurs is we port fluid through our system on top of this servo piston, and it shifts the yoke to this zero cam angle position. At this point, we're not getting any displacement out of the pump, and the pump will maintain the compensator setting. So let's talk about relief valves. Every hydraulic system must have a relief valve. It doesn't matter whether it's a fixed displacement pump or variable volume. I show two examples of relief valves here: a direct acting relief valve and a pilot operated two-stage relief valve. I don't need to get in and talk about the differences between the two. What happens though is my pressure comes in, runs against a poppet and a spring. When I hit my spring setting, it lifts the poppet and ports flow to tank. Both of these work exactly the same way. So with a fixed displacement pump, whether it be vane or gear, anytime that shaft is rotating, that pump is putting out flow. So if we block that flow, the pump continues to put out fluid, which could be a very bad thing. That fluid has nowhere to go. And if it doesn't have anywhere to go, boom, we're going to have a problem. Something is going to blow up. So a pressure relief valve in the circuit prevents that boom from happening by relieving pressure to tank. In a fixed displacement circuit, the relief valve sets the maximum system pressure. And when I go to a variable volume circuit, the pressure compensator on the pump now sets the maximum system pressure. And the relief valve is only in the circuit as a safety in case the pressure compensator fails. If the settings of the relief valve and the compensator are too close together, they may fight with each other. And if that occurs, we could be dumping pump flow to tank, creating excessive heat. So compensators and reliefs must be set properly to prevent this from occurring. So here's how we go about setting. This is the correct procedure. To start with, I'm going to back my compensator and my relief valve fully off. Then I'm going to start the pump. I'll adjust the compensator in several turns because what I need to do is get the compensator pressure set above where my relief valve setting needs to be. Once I've done that, I'm going to turn the relief valve adjustment in until the maximum system pressure is achieved. And you may have to turn the compensator adjuster in a little further to reach that setting. Once the relief valve is set, lock down the lock nut on the adjuster. One thing I want to point out is note the sound of the pump and the motor. The sound indicates that the pump is loaded and all flow is being dumped over the relief valve. Now I want to set the compensator, so I'm going to back out the compensator adjustment until the pressure drops below the desired pressure setting. Then I'll screw in the adjuster until the pressure setting has been achieved and lock down the lock nut on the adjuster. Again, note the sound of the pump and the motor. The pump will not be loaded now, and the sound indicates the pump is compensated and not running under load. There should be normally a minimum of 250 to 300 psi between the compensator setting and the relief valve setting, with the relief valve being higher. All adjustments are made pressure increasing due to the hysteresis across the components. So if you go past the setting, you need to back it off, get below the setting, and then bring it back up to the setting that you need. Quick and easy, that is how to set up relief and a compensator on a system. Now I want to show you a couple of compensators. And you'll see these are the two most common compensators that are out in the field. The first one is a single stage compensator. We call that a DR compensator with Rexroth. And that's just a straight pump compensator. When you hit the setting of the compensator, it destrokes the pump. This one is a two-stage compensator. We can also use it to do a few other functions in the circuit. I'll talk about that in another video. One thing I want to point out is we're going to adjust the bigger pistons. The one that you see is smaller, we call that one DFW. Don't fool with it. I also have a relief valve here, and this is just an example. So this is a cartridge style relief valve in a 90-degree body. There's our adjustment there. So when we go to adjust this, that's how we're setting the relief valve, and adjusting the compensator, that's how we're making the compensator adjustment. Now, if you have any further questions or you would like to talk to me about some formal training, please give me a call. My cell phone number is there and my email is there, and I look forward to hearing from you. Thank you.